Hi, and welcome to Chemistry 111, experiment number 11. This is our second to last experiment, vitamin C analysis by redox titration. The goal is to find out how much vitamin C, that's this right here, ascorbic acid, is in a vitamin tablet, and we'll be titrating it not with a base, even though this acts as an acid right here, ascorbic acid, but rather we'll be doing a redox titration. We'll be using iodate in the form of potassium iodate in order to do this titration. Now, a little bit of background. Here's some chemistry, and this gets a little bit complex, so bear with me. We're using iodate, and we're reacting it with ascorbic acid, but here's the relevant chemistry. Iodate can react with iodide and acid to form three equivalents, 3 molecules of iodine per molecule of iodate, along with 3 molecules of water. Now you should be asking yourself, wait, I thought we were titrating iodate with ascorbic acid. Where's the ascorbic acid? It's not there. Okay, let's continue. Each molecule of iodine that gets generated here can react with a molecule of vitamin C, that should say, that feeds into the original reaction. So vitamin C reacts with iodine, which is not what we were using, it's a product of it, to make dihydroascorbic acid, which is shown here, and 2 molecules of acid, 2 molecules of iodide. The acid and the iodide are right here and here. So you can see how these tie into each other, but it should seem a little weird, sort of a chicken and the egg problem, which came first. We need the products of one to react with the other. Suffice it to say that it simply works. Also note that ascorbic acid is in fact an acid, but there's no carboxylic acid on this functionality. The acidic hydrogens are right here and right here. When it reacts, it will form dihydroascorbic acid. Notice that these alcohols, and organic chemists recognize that these are in fact enols, since you have an alkene directly attached to an alcohol. And there's a lot of organic chemistry associated with that I will skip, but you've lost those 2 hydrogens when you form dihydroascorbic acid. So that's where the H pluses come from, and that's how ascorbic acid acts as an acid. Okay, let's continue with our chemistry here. Now, each molecule of iodine that we've formed right here can react with the iodide that's generated from this reaction here. And it needs a little bit of starch. This could be in the form of the tablet itself, but we'll also add a little bit of starch as an indicator. And it can form I3 minus triiodide. And it forms a starch complex with that. That's blue. And then finally, that's the thing turns blue and you're good to go. Okay, throw all that stuff in your mind, combine it, compress it, try to make sense of it, and realize that each molecule of iodide will react with 3 molecules of vitamin C. So it's not a 1-to-1 titration. You'll be using far less iodide than would be necessary for a 1-to-1. Each one of these can generate 3 molecules of iodine, which in turn reacts with the vitamin C. So it requires far less iodide than you would need if the stoichiometry was 1-to-1. Fine. I hope you made sense of that. Okay, the procedure, fortunately, is relatively brief. We'll take about 0.2 grams of the vitamin tablet, grind it up in a mortar and pestle, add water to it. That's what we'll throw in the beaker that we'll titrate it into. And we will put 0.2 molar iodate in the form of potassium iodate that I believe is already prepared for you into the burette and drip the stuff in. From that, we should be able to find out how many milligrams are present in the vitamin C tablet. And here's the relevant calculations. First, once you do this titration, the main thing you'll end up with is the milliliters of iodate that it needed to turn blue. Agreed? So you'll have 2 pieces of data. You'll know the molarity of the iodate. It's given as 0.200 molar. You know the volume of the iodate that you dripped in. Now, if you kept that in milliliters, they would not cancel properly. So make sure that you convert that to liters. And that'll tell you, notice how liters cancels, the moles of the iodate that was needed to react with the vitamin C. Now that's only 1/3 really of the moles, the molarity of the vitamin C, right, since it's a 1-to-3 ratio. So we can now use that to see how many moles of vitamin C were in the sample. This says 2 period. This does not mean 2 moles of iodate. See that period? That's 1, 2, 3, 4. So ignore that too. The moles of iodate are equivalent, each mole of iodate is equivalent to 3 moles of iodine, and each mole of iodine is equivalent to 1 mole of vitamin C, since that's how it reacts. And so you basically are going to have a threefold multiplier here to get the moles of vitamin C. Now we need to know how many milligrams are present. That's pretty easy. How many grams is a mole? 176.13. If you add up all the carbons, hydrogens, and oxygens in this one right here, that's what you'll get, see? And so convert from moles to grams, from grams to milligrams, and you should find out how many milligrams of vitamin C are in, no, not your tablet, because we didn't use a whole tablet. We used only 0.2 grams. So if the tablet was 1 gram, then I think you'd have 5 times as much. I'm not going to show the calculation to figure out how the mass of the vitamin C is in each tablet, but I can see, you should be able to see that there's a multiplier involved. We used a fraction of your tablet, so just do the math required there to find out the mass of vitamin C in each tablet. And in fact, these are the calculations that are required, so I've even numbered them for you. So moles of iodate needed to titrate the sample, boom. Moles of vitamin C in your sample, kaboom. Milligrams of vitamin C in your sample, whammo. And average milligrams of vitamin C in your tablet, yikes, do it on your own. Average milligrams of vitamin C in your tablet, well, you're doing 3 trials, so take the average of each one. The procedure is very straightforward, and perhaps it'll be brief, we'll see. I have a feeling that things are short enough that if you run into a problem with a titration, it didn't go well, simply abandon it and get 3 good trials. So you'll take 0.2 grams of vitamin C tablet, you'll grind it up in a mortar pestle. If it's written as an unknown, I don't know if all the samples are identical, make sure that you identify the sample that you used. Put some 0.2 molar potassium iodate into your burette, drip that stuff in till it turns blue, record it to the 100th of a mil, that's 2 decimal places. Do this for 3 trials, hope you get nice close agreement, that's always a good sign. Be sure to identify your sample, run your calculations in class before you leave, and answer the post-lab question. A lot of students, well, not a lot, but I always get 1 or 2 that just forgot about that and they end up getting a 0 for 5 on the post-lab. Okay, so not many special notes here. Safety is not particularly dangerous, just a little bit of vitamin C, a little bit of iodate, and record your burettes precisely, your volumes that is. All the liquids can go down the sink except the iodate that's in the burette. That goes in a waste bottle in the hood. Okay, enjoy this lab, and I'll see you guys at 6:30.